Artificial gravity sounds like science fiction, spinning spaceships, magnetic boots, or that button you press to magically make your coffee stay in the cup. But what if we actually had it? Not in theory, not in Star Trek, but real switch on and off at will artificial gravity. Let's start small. A 70 kilos person on Earth weighs about 686 newtons. That's Earth gravity, 9.8 meters per second squared. If we could artificially generate that same acceleration anywhere, we could stick astronauts to floors, keep coffee in mugs, and stop people from turning into floating yogis. Space would become boringly normal. But creating gravity isn't easy, because gravity is not just a force, it's geometry. Einstein told us that gravity is the warping of space-time. So, to fake gravity, we'd need to either warp space, good luck with that, or simulate its effects. Enter artificial gravity by acceleration. Spin a spacecraft in a circle, and the passengers get pushed outward. Centrifugal force. If you want Earth-like gravity, the math says the ship's radius times angular velocity squared has to equal 9.8 meters per second squared. So, a rotating habitat 100 meters in radius would need to spin at roughly 1 RPM. Totally manageable, but also dizzying. Spin too fast and your inner ear declares mutiny. Now imagine a world where we don't spin things to get gravity, we just flip a switch. Say we invent a magical gravity generator. We drop one on the moon, and suddenly it has Earth gravity. Cool, right? Now take that further. What happens if we put one in space and turn it on? You've just created a gravitational singularity. That's not just a cool phrase, it's a physics nightmare. If your gravity generator simulates mass without the mass, you're bending space-time without energy. According to the Einstein field equations, that means you're violating the conservation of energy, Newton's laws, and probably some international treaties. But okay, let's pretend our generator just works. What could we do? First, space toilets. No more zero-G poop floating through the ISS like a haunted sausage. Second, bones and muscles saved. Astronauts lose 1 to 2% of their bone mass every month in space. With artificial gravity, that problem evaporates, literally if the generator's too strong. But here's the kicker. If we can control gravity, we can weaponize it. Drop a 10G gravity bomb on a city, and suddenly everyone weighs 10 times more. Cars collapse, people can't move, buildings crack under their own weight. Gravity becomes a force not just of nature, but of geopolitics. Congratulations, you've invented the most boringly terrifying superweapon. Could we use it for good? Yes. Want to simulate Mars gravity, 0.38 G, on Earth to prepare astronauts? Easy. Want to turn off gravity in your living room to float your cat around for YouTube views? Done. Want to make escalators obsolete by walking on gravity-inverted walls? Sure, but it all hinges on one thing: power. To simulate Earth gravity across a small spacecraft would require millions of newtons of force, roughly equivalent to lifting an elephant every square meter. If your artificial gravity device could do that without melting through the hull or collapsing into a black hole, you're not an engineer. You're a wizard. In short, if we had artificial gravity, everything changes. Not just space travel, but architecture, warfare, medicine, and dance parties. It'd be revolutionary, but also probably very, very expensive, and maybe a little too fun to be allowed. If you enjoyed this wild thought experiment, don't forget to like, subscribe, and hit that notification bell so you don't miss the next deep dive into absurd science. Thanks for watching, and I'll see you next time.